Very good afternoon. Welcome to contact session number 6, January 31st, 2026, infrastructure management. Let's start with the positive point. Very good afternoon to everybody. Thank you for your wishes. And thank you for respecting the request and responding. Am I audible? You're able to hear me, you're able to see me, you're able to see the presentation. Presentation I have not shared. Okay. Okay. So basically, all of us is looking for happiness. All of us want to be happy. When you want to be happy, where should you be looking for happiness? The famous Sufi literature, the character Mullah Nasruddin is very famous. Mullah Nasruddin was very sad one day. He was sitting there and he was crying. A close friend who visited him asked, "Why are you so sad?" In response, Mullah began to cry. He said, Nasruddin said, "My maternal uncle died last month. He left me with a lot of property before dying. I thought of him and I'm crying now." So for that, the friend trying to console him said, "Don't be worried. Don't be so sad. He was 80 years old. Obviously, he has to pass away. Death is natural. Why are you so sad? You should be very happy that you got his vast property." Again, Nasruddin was inconsolable. He started crying. He said, "You don't understand my grief. My friend, last week my paternal uncle died. He left me millions of rupees in the bank account in my name." He was weeping in an uncontrollable fashion. Now the friend got really confused. He said the same thing. "Now I know your paternal uncle was also very old. Now you should be doubly happy because he left you with cash." Mullah did not stop. He was crying again. His friend asked out of irritation, "Why are you crying like an idiot?" Mullah said, "My sorrow is even worse than that. My grandfather, who's over 100 years, died yesterday. He left me some stocks and equities worth 20 crores. He was extremely rich. Now the friend was really fed up. I said, "Really fail to understand why you should be crying at all. They have done the best things for you." Mullah sniffed, wiped his tears, and explained, "My maternal uncle, my paternal uncle, my grandfather, who are all extremely rich, are all dead. Now I don't have any more uncles left to die. Who is going to give me more property?" So this implies to tell us a very important truth, that is, greed is one of the sources of unhappiness. If you allow it to expand unreasonably, then the joy or peace of mind would be the casualty. Happiness and satisfaction are within us. It's like water poured into the cracked pot. You will not remain in it. Similarly, people without contentment cannot be happy. They will only worry about what they don't have and not be happy about what they have. So, when our mind is filled with blind spots, we cannot see the good things in life. Once you remove those blind spots, you would be filled with joy. You would have heard a lot of people say this: if I get this, I'll be happy. If I go there, I'll be happy. If I do that, I'll be happy. Never attach anything to your joy and postpone your happiness. Even if you get that job, or even if you don't get that job, keep your happiness and don't allow those incidents to decide whether you should be happy. Before I came into contact with the object, I was not happy. After I came into contact with that object, I'm happy. So when you do that, you are saying that happiness comes from an object. So don't be victims of limiting logic. Create energy of rejoicing in what you have rather than complaining of what you don't have. When there is trust, there is no fear. The highest knowledge is the knowledge of happiness. So with that, that's my story. And we take you into this wonderful world of infrastructure management, where we'll be talking about starting with the 7 R's of the high availability. And then we go into, did anybody say anything? Somebody spoke something. Seven R's, and then we will take you into the production acceptance process. My slides are visible, right? You're able to see my slides? Yeah. Somebody confirm yes.
Yes, sir.
Sachin Kumar Singh. Chandana, I can't hear you. When you're speaking, I can't hear you.
Yes, sir.
Visible, okay. Thank you. So important notes to the students: be alert, answer the questions, be active, don't sign in and leave. 7 R's, desired traits, going to be the availability process. What is that is expected? So what is availability? Availability is the process of optimizing the readiness of production system by accurately measuring, analyzing, and reducing outages those production systems. As an ITSM manager, you will need to clearly distinguish the key terminologies related to availability. So this is uptime, downtime, slow response, high availability, and fault tolerance. The measurement of availability plays a key role, and preferred measurement method is rolling average. So you need to commit on the availability and carefully study the need when the business is expanding. While designing the availability part, please remember the 7R technique: redundancy, reputation, reliability, repairability, recoverability, responsiveness, and robustness. Constantly assess the maturity level of the availability process to deliver for the dynamic business environments and constant updates. Let's say you want prioritized characteristics for a availability process. You need to have these high priority characteristics: knowledge, system software, network software components, database systems, power air conditioning systems, ability to think and act in a very tactical fashion. Medium, knowledge, software configuration, hardware, backup, everything. These are low priority items. So what are the 7 R's? The basic goal of all availability process owners is to maximize the uptime of the various online systems which they are responsible for. They have to make that system completely fault tolerant. But there are certain constraints, both inside and outside the IT, which makes this challenge close to impossible. Some of the factors working against that elusive goal of 100% availability includes budget, component failures, faulty code, human error, design flaw, natural disasters, unforeseen business shifts, such as mergers, downturns, and political changes. There are several approaches which has been taken to maximize the availability. Let's look at these 7 R's, which will help you to improve the overall level of the service. Redundancy, reputation, reliability, repairability, recoverability, responsiveness, and we're adding one more. 8th one is resilience. What is redundancy? Redundancy is practiced by manufacturers by designing this into products. Power supplies, multiple processes. Eliminate as much as possible any single points of failure that could disrupt the service available. The reputation: to build IT environment using products like servers, disk systems from suppliers who have a good reputation. IBM, HCL, Wipro. I don't think Wipro manufactures any product. HCL, IBM. This refers market share. Then the reliability pertains to the dependability of the components to function under the stated conditions. So it depends on the building process, validity by references, component reliability analysis. Repairability talks about how quickly and easily you can fix the errors. Okay. Recoverability refers to the ability to overcome a momentary failure such a way that there are no impact on end user availability. Responsiveness, it's a sense of urgency. All people involved with high availability need to exhibit in terms of quickness and efficiency when needing to respond to problems. Robustness is about the overall design of the availability process to withstand internal and external forces that could disrupt and undermine availability in a weaker environment. Resilience. Systems must using capabilities like ML to learn patterns to adapt to the changes. We'll take a example. How do I achieve high availability systems? This is achieved by designing and implementing infrastructure that ensures continuous uptime and minimizes the downtime. This involves using technology, architecture, process, even in the face of failures, maintenance, and unexpected disruptions. Here is how high availability is typically achieved. Redundant system and hardware. Redundancy means having multiple instances of the critical system component so that if one component fails, another can take over without service disruption. Dual power supplies. Servers and data centers often have dual power supplies connected to different sources to prevent power failure from causing downtime. Redundant network interfaces ensures network traffic can be rerouted in case of network failures. Balancers Sorry, I'm back. So the load balancing will distribute the traffic across multiple servers to ensure there's no single server is overwhelmed. So one server fails or goes down, the load balancer will automatically route traffic to the remaining operations. So if you take a web app application, so it can distribute user requests across several web servers, ensuring that even one server fails, the application remains. The next high availability mechanism is the failover mechanism. So what is a failover mechanism? Failover mechanism is the process of automatically switching to a redundant or a standby system when the failure occurs. So there are two types of failovers. One is called as an active passive failover, another one is called as an active active failover. The secondary system is ready in an active passive failover. It is not started, but when the primary active system fails, the passive system remains idle until needed. An active failover system, multiple systems that are actively running and they handle traffic simultaneously. If one fails, the other continues operating without any disruption. So you will need this in a database cluster. If the primary database server crashes, the failover mechanism automatically switches to a standby database with minimal downtime. Clustering is the fourth way. So what is clustering? Clustering involves, for high availability, connecting multiple servers to work together as a single system. If one server in the cluster fails, another can immediately take over the workload. So they are, where are they used? They are often used in databases, file storage and web servers. Geographical redundancy is when there is a catastrophic failure in a particular region. There is a geographical redundancy which ensures that the services can be quickly restored by having data and services replicated across different geographical regions. So many companies maintain secondary data centers in different locations. They're called as disaster recovery sites, which can take over the event of a failure in a primary site. So a cloud provider like AWS or Microsoft Azure can replicate data across multiple regions, ensuring that if one region is affected by an outage, service continues in other regions. Then comes the data replication or backup, which ensures that the data is copied in real time or near real time across multiple storage locations. If one storage device fails, the data can be accessed from the another device. So you can have synchronous replication or asynchronous. Synchronous replication is real-time replication of data to multiple sites so that data is consistently available across multiple sources. Asynchronous is data is returned to the primary storage and the secondary storage devices gets uploaded with a small slight delay. Automated monitoring, continuous monitoring of systems health and performance ensures that potential issues are detected early before they lead to the downtime. So some of you might be using these tools, Nagios, Zabbix, Datadog, for the monitoring of performance and resource usage and potential failure. So you can have alerts, such as when the CPU reaches 90%, disk space is too low. So the system sends an alert so that the administrators will fix before the system will fail. Then you have the disaster recovery plan, which outlines the steps to restore critical systems and operations in the event of a major disruption. So the high availability is enhanced by having automated failover systems. So the disaster recovery plan will ensure that you effect a quick recovery when these failover systems are overwhelmed. So how does this work? They maintain a backup system, replicating data across different geographical locations. So a SaaS company regularly performs DR drills to simulate a data center failure. Then we have rolling updates or zero-time deployment, downtime deployment. Rolling updates involve updating portions of a system without taking the entire system offline. So this ensures that services remain available even during updates and maintenance. So we can go for a blue-green deployment. The strategy involves running two environments simultaneously. One environment serves live traffic while others is updated. After update or tested, traffic is switched to the updated environment. So a web application running on Kubernetes can update parts of its service one at a time while keeping the, then you have the SLAs. SLAs and continuous testing will keep your system up. So continuous testing ensures the system is resilient. So how do we do this? We do this by doing a failover testing and a chaos engineering. Failover testing is simulating the failure of critical components to ensure the system correctly switches to a backup. And then chaos engineering deliberately causing failures to test the system's ability to recover. So Netflix uses chaos monkeys, which will randomly shut down servers to test their system's fault tolerance and ensuring high availability. So key technologies for high availability: load balancers, clustering software, database application monitoring, and cloud platforms. So what are the common metrics for reliability? We'll use MTBF and MTTR. So common metric for reliability of the component, the applications or system in an average. Okay, friends, I'm locking the class. If any of you are already inside here, gets logged out, send me a chat, I'll open. So then it's locked. But we have 7. A common metric for reliability of components. So this is the measure of the average length of time an entity is expected to stay up and operational over a given period of time. So this time frame is often a year, and it is known as a sampling interval. The formula used is to compute sampling interval divided by the number of failures during sampling interval. Then we also have another common metric, which is there to check the average or the mean time to repair. Is sometimes interpreted as the mean time to recovery as well. So the mean time to restore or the mean time to resolve, it measures the average time it takes to do the actual repair. So the formula used to compute MTTR is sum of the repair times, number of failures. So these are some of the formulas that you better remember, and there are probability of getting them as questions in your exams. Chances are there. So this is an example of estimating MTTR and MTBF. I also have given a few examples towards the end so that you can use that for your exam preparation. So it failed on these dates, totally 4 failures, time to repair in minutes. Total repair time is 164 minutes, and it was down in 1 year. So the total uptime in 12 months, there were 4 failures. So if I want to find out how much time it took to repair one failure, I will have to divide 164 by 4. So on an average, whenever a system fails, it took them 41 minutes to repair it. MTBF tells you the total uptime is 12 months divided by number of failures. So every 3 months, there is a failure. This is a very important topic as a part of ITSM. We will see this, and then towards the end, we will look at case studies using the 7R technique and also the availability process evaluation metrics. So I want to implement a production acceptance. What is this production acceptance? Why do I need it? What is the purpose? If you remember, you would have studied these IT infrastructures and projects. There you studied a lot about ITIL. ITIL brought out certain concepts such as incident management, problem management, change management. So whenever when it's happening only for the first time, it's an incident. When it gets repeated, it becomes a problem. Then towards this incident and problem, you'll do a deep dive analysis, and if you find out there are some changes required, then you'll have to do the change management. Once the change is done, you're ready, then you will talk about how to bring that into production. So that is what is called as production acceptance process. You have 14 different steps. Identify the executive sponsor, process owner, executive support, assemble the production acceptance team, identify, develop policy, nominate appropriate design, appropriate forms, document the procedures, execute the pilot system, conduct lessons learned, revise policies, formulate marketing strategy, follow up the improvements. Identify an executive sponsor. An executive sponsor is necessary to ensure ongoing support and cooperation between the departments. The sponsor could be the CIO, the head of the infrastructure group, The higher the level of executive sponsor, the better it is. The executive sponsor is the champion of the process, and he is the person who is responsible for selecting the process. The process owner should be a member of the infrastructure organization. So the person will be interacting frequently with the programmers who developed and will be maintaining the system. Being able to evaluate application documentation and to communicate effectively with the program, developers are two additional characteristics that are highly recommended as a process owner. Top prioritize characteristics. Right? Knowledge of application is expected to be very high, and ability to evaluate documentation and communicate with the developers. Once you are ready, you need to solicit executive support. So the production acceptance requires much cooperation and support between the application development and the infrastructure department. So executive support from both of these departments is required. So the support should be solicited from both these departments to ensure that policies and decisions about the design of the process are backed up and pushed down from higher levels of management. So they need to also say, hey, do it. The process owner should assemble a cross-functional team. Whoops. Fine. Thank you. One second. Okay. So we assemble the production team, cross-functional team, to assist in developing and implementing a production acceptance. So who should be there? The team should consist of key representatives from development, operations, technical support, help desk, capacity planning, and database administration. For large development projects, say, could be 400 programmers, right? So we bring 4 groups: finance, engineering, manufacturing, logistics, one from each group. So when we do this, it will lead to a successful result. So for an effective production turnover process, the agreed upon requirements at the start, right? One second. So we have agreed upon requirements at the start. Requirements need to be prioritized. Some of the common requirements with high priority. So we need to ensure that operations, technical support, network services, and database administration are all involved early on in implementing a new application. Ensure capacity gathering requirements, which are compatible with capacity planning process. Provide application documentation to operations, production turnover. Develop and enforce management policy statements. Your cross-functional team should develop policy statements for the production acceptance process. So the policy statements help to ensure that issues such as compliance, enforcement, and accountability stays with you, right? All major new versions of the existing production application are to go through formal production acceptance process. Any application deployed through production acceptance process that require substantial desktop capacity upgrades and to provide specific requirements to capacity planners with sufficient lead times. After you do that, the next step is for us to nominate a pilot system. So a pilot system is a small scale version of a application, which is used to try out new processes, functions, and features. So when a production acceptance process is implemented in an environment which has never had a major change, you cannot put a huge change into the production. So what you do is the most effective way is to introduce a new method of production turnover on a smaller scale with minimal impact pilot system. So consider putting only a small portion, initial portion of a major system through the new process. So there's a business. So you start here, you have an IT acceptor who's a technical architect with technical specifications. Pilot acceptance criteria, the business acceptor will accept, then the acceptance of the environment. The pilot's site agreed and signed off, then we go for full acceptance criteria on the production rollout with a full sign. Then what we need to do is, right? During the requirement step, team will discuss the quantity, types, and characteristics of forms to be used with the production acceptance process, right? Hold on. So the primary production acceptance form, the capacity planning form, the customer acceptance form, the service desk testing plan, these are all some of the forms that we will need to get done. The capacity form is for periodic updates to resource requirements. The customer acceptance form is for user feedback prior to deployment. The service desk form is for okay. Just give me one second. Just one second. I'm here. So the service desk form is for anticipated calls during the startup. The test plan is for developers to show functions and performance of the new system. The lessons learned form is for follow-up and improvements after full deployment of a new system. So if you take a look at this application, right? This is an appropriate form. Production acceptance request form, actions required at time of project approval. So this is basically the so the document the procedure. So the documentation of any system process is important. So in case of production acceptance, it is very important because such large numbers of developers will be using it. So the documentation for these procedures must be effective and accessible. Ensure the documentation is both of high quality and high value. So we take an example of a pilot system. A software pilot system is typically a prototype. Let's say if I want to do a warehouse management system, to implement a pilot system for managing the storage, movement, and tracking of inventory in a warehouse, and to evaluate the system's integration with the existing logistics workflow. So the inventory management is there to track the real-time stocks, adding new inventory in the systems, into the systems, managing stocks across different locations within the warehouse, processing incoming orders from the clients, managing picking, packing, and shipping of orders, and updating stock levels automatically after an order is processed. So warehouse layout visualization. So I can visualize the layout of the warehouse so that I can optimize the storage, item storage, and retrieval, provide instructions for item picking based on location, barcode scanning, basic analysis and reporting, tracking, processing times, orders, order processing, monitoring stock movement, generating reports for the inventory, user access control, different levels of access for warehouse staff, managers, and administrators, secure login systems for tracking the user activity and change. So the pilot warehouse selection, single warehouse is chosen to implement the pilot system. So we will bring all the required necessary hardware for that, for barcode scanners, label printers, and then training for the staff is coming. Then initially the pilot system is implemented for a subset of products. The scope can expand as system proves successful. The pilot system is integrated with the company's existing ERP software to ensure seamless flow of order data, inventory updates, and financial records. So then during the pilot phase, user feedback is gathered from the warehouse staff, and they will identify the shortcomings based on the usability and readability. After we have done with this, we will go with the success criteria and low error rates in tracking orders and inventory. We'll go with the positive feedback on ease of use from warehouse employees, reduce time in inventory management tasks, do full integration with the existing systems without significant data issues. Post-pilot review, after running the pilot for a defined period, key performance indicators such as inventory accuracy, order fulfillment, and system updates, uptimes are reviewed. So based on the findings, the software may undergo further development and testing, followed by a decision to scale the systems across all the warehouses. So this example shows us a very clear structured implementation with a clear goal. So you have done with the pilot system, you have executed the pilot system. Next, user testing and acceptance plays a major role. User acceptance testing starts with the development, quality assurance, user acceptance testings, and production. And if you look at it from a comparative perspective, from a software development process to the testing methodologies, the client needs are mapped into acceptance testings, requirements mapped into system testing, designs into integration testing, and coding into unit testing. So what are my objectives when I go with the user acceptance tests? I'm doing the UAT to confirm that the system product performs business functions as intended for business requirements. I'm there to confirm that the system product is usable from an end user perspective, to confirm that the system product is compliant and legal requirements, and to certify that the system product is deemed ready to be moved into production. Are there any expectations from an UAT? Yes. UAT assumes that the systems or product is functionally stable and that no critical functional defects will be uncovered. Right? Not expected to be extensive as system testing. So it's a go or a no-go recommendation. Take an example of an UAT for a customer relationship management system pilot. What is the objective here? The objective of the UAT is to validate whether the CRM meets the business needs and the user expectations. Contact management, I'm going to test adding, editing, deleting customer contact information. Then sales pipeline, I'm going to validate the functionality for managing leads, tracking deal stages, and generating sales report. And then I'm going to do email integration. I'm going to verify the system's ability to send and receive emails within CRM and auto log interactions. I'm going to test the generation of reports on sales activity, customer engagement, and overall CRM. Then I'm going to do a role-based access control to ensure that users with different roles have the correct permissions and access to appropriate form. So let's start with the preparation. Set up the CRM in an UAT environment that mirrors the production setup. Ensure data migration and integration with other systems. Email servers and ERP are configured. You will go and get the participants from the sales team, customer support team, and the management team. Then we are going to do 3 test cases. The first test case is going to add a new lead to the CRM and track the deal stages until the closure. This is the test case. CRM track, close deal. This will consist of various test scenarios. The first test case, add new contact to the CRM. A sales rep will add a new contact. So what are the steps? Log into the sales rep, navigate to the contact section, add a new contact, save the contact, expected results. A new contact should be saved and visible to the contact list. The system should display a success message. So whatever happens, you will fill it up in the UAT. Result. Track a new lead through the sales pipeline. Log in as a sales rep. Navigate to the lead section. Add a new lead with information about the deal. Move the lead through different deal stages. Initial contact, negotiation, closed, or won. Generate the report on sales pipeline. The lead should move through the different stages and report the changes. Fill the results. Last test case, resolve customer support ticket. Log in as a customer support, open the ticket, update the ticket with troubleshooting steps, close it, see whether the expected results is resolved with the resolution date. So the UAT example, the participants execute the test cases, record whether each test passes or fails. Defects are logged into tracking tool, categorized by severity. Developers and the UAT team review the defects. Critical and major issues must be resolved before the UAT sign off. The UAT sign off, once all test cases have been executed and any critical issues have been resolved, the UAT participants sign off indicating that the software meets their needs. How will you check the success criteria? 100% execution of critical test cases. All critical test cases must be executed and defects must be resolved. No critical or major defects. UAT can only be signed off if there are no critical or major issues. UAT participants confirm that the CRM system meets the requirements. It is user-friendly. It also integrates seamlessly with other tools. Then you sign off. Outcome, once UAT is successfully completed, the CRM system is ready for full-scale deployment across the organization. Once you have completed your process with regards to the lessons learned, you will be doing after the pilot, you will be doing a lessons learned. So the participants should include representatives from the user community, software development team, and help desk. So this is how you would do a lessons learned for your pilot system. So the pilot included 50 users from sales and customer support, and we ran for 3 months. What was the expectation? The expectation was to improve the efficiency in tracking the customer interactions, managing the leads, and enhancing the customer service. Is the quiz visible, boys and girls? Just give me, somebody confirm that for me. Is the quiz visible? The lessons learned session was organized after the completion of the pilot versus the outcome. Okay, thank you. So we have to prepare for the lessons learned session. The goal is to capture the feedback on what worked, what did not work, and how the system was improved before we go with a full-scale development, deployment. So who are the attendees? IT team, sales and customer support, project manager, vendors, business analysts. So the company recently conducted a pilot's deployment on new cloud-based customer relationship. We have an overview of CRM pilot goal, scope, timeline. Explain that the session purpose is to learn the pilot experience, not assign any blame. Review the project goals. Did the pilot meet? What was the expected objectives? Review the KPIs. Discussion on what went well. Discussion on what did not go well. Discussion on areas of improvement and next closing steps. All this will be conducted. So we're going to start the session. To conduct the session, we're going to start saying, hey, what went well? First point was smooth data migration. The customer data from the legacy system moved into the CRM. Thumbs up. We had minimal downtime, no data loss. Super. What is the participant feel? Participant said, hey, wow, great job, my guys. The data integrity is perfect. Everything went smoothly. Awesome. We have access to all the data. Super. +1. User-friendly interface. Hey, how is the new interface? Oh man, it's so easy to navigate. Very easy to learn. After a short training session, the user says, it is very intuitive. I was able to perform the task faster than the old system. +2. Super. Automated reporting. The new CRM provided automated reporting tools, reducing manual reporting by 50%. The automation of the sales report saved me hours of work, allowing me to focus on the client interactions. Super. Now, what did not go well? There were performance issues during peak hours. The systems experienced slowdowns during peak usage times, especially when multiple users were generating reports. 10 users were logged in, system lagged significantly, and we had to wait for minutes low. Analysis, the performance bottleneck. Once you have a problem, you will go do the analysis. The bottleneck was traced to insufficient cloud infrastructure. The pilot did not scale up the resources. And then some users reported difficulty in using advanced features like lead scoring system, etc. They said the basic features were easy to use, but the advanced tools needed more in-depth training. Many of us struggled. So the initial training sessions were too focused on basic functionalities. Now we are going with advanced features. Integration with the existing systems. The CRM integration with the existing other internal systems were inconsistent. Some users experience issues with automatic data sync. We had trouble syncing CRM data with email system. Sometimes emails weren't logged and manually update customer data. So what could be improved? This is the opportunity. So set up, improve scalability, set up dynamic resources. Upgrade your cloud infrastructure with auto scaling configurations to handle periods of high demand. Provide advanced training sessions focused on CRM like lead scoring, customer segmentation, reporting, and automation. We should design more targeted training modules. Work with vendors to address API problems, ensuring seamless data synchronization. So then we ended up with the recommendation that we need to conduct deeper integration testing and possibly work with third-party vendors to ensure smooth data flows between systems. So the insights from the sessions were captured in the lessons learned report. Pilot objectives, key outcomes, smooth data migration with no data loss, challenges, all will be captured. Then you will have to document the findings. What are the recommendations? Implement cloud infrastructure, conduct additional trainings, resolve. So what is the next plan? Action plan, set up follow-up meetings, schedule advanced training sessions, and assign developers on API optimization. So last is follow-up, closing, and next steps. Plan a follow-up session after full deployment to review how lessons learned were implemented. Create a system for continuous feedback during the next phase of rollout. So the session highlighted the importance of scalability, better training, and optimized integrations. So a well-conducted lessons learned session like this will help your team reflect on both the achievements and the challenges. So you'll be able to address the performance and the training gaps in the organization. Then you might have to revise the policies and procedures based on the lessons learned from the pilot. So we're going to have to revise the policies, the procedures, the forms, the test plans, some training techniques, the support staff. So once you make these revisions, this must be agreed by the entire cross-functional team prior to full deployment. Then comes the marketing side. Regardless of how thoroughly and effectively a cross-functional team designs a production acceptance process, the process does little good if it is not supported by development groups. So you need to formulate a marketing plan where you go and say, hey, what are the advantages? What are the benefits of using this process? So you also look to get active support of executive sponsors and peers. Examples of any quick wins: users, service desk personnel, and support staff testimonials will be of great use. So you follow up for ongoing enforcements and improvement. So improvement processes such as production acceptance often enjoy much initial support. Right? 10 students drop. Lazy kids. Ten minutes before the class got completed, 11 students logged out, requesting the admin to track those students and mark them as absent for this session. So changing priorities, conflicting schedules, budget constraints, turnover of staff management. So one of the best ways to ensure reviews, postmortems, and lesson learned. So you can improve overall quality, enforcement, and effectiveness of the process. So assign deliverable. Team member will prepare the deliverable. Draft will be reviewed with the team leader. If required, corrections will be made. And then review with the customer. If required, corrections will be made. And then review and approve project acceptance date. How do you assess an infrastructure availability process? If I want to assess an infrastructure availability process, the categories are executive support, process owner, and process documentation. So overall efficiency of the process will consist of supplier involvement, process metrics, process integration and streamlining, customer involvement, service metrics, and training of the staff. Right? So here we will have an assessment infrastructure availability checklist where we check all of this and we give a weightage and then we give a rating and then we multiply and then we get a final output. I'll show you a use case. How do you measure the availability process? To measure the effectiveness of the process, there are 10 categories which we have listed here, starting from executive support to the training of the staff. So each category is rated relatively on a scale of 1 to 4, 1 indicating no presence, 4 indicating large presence. So you see here, executive support is small, process owner support is large, customer involvement is large, service metrics is large, like that. Okay. So you have 10 categories within this process and you give a point, 1 to 5, and then they multiply and they arrive. So take a company. A company is well-established aerospace firm, 50 years old, 80,000 workers, 400 in IT, 1,200 desktops, 350 production applications are running daily. So the company A was staffed with 2 competent individuals. Little was documented. Everything was inside the brains of these 2 people. Production services were also segregated. Operations did a good job in collecting meaningful metrics, but they did not use the metrics and analyze it. If I look at the strengths of company A, they were willing to try new techniques and new technology. They committed to continuous process improvement. They hired and developed technical competent staff. They were willing to collect the meaningful metrics, but where is the weakness? They tend not to interact with members of the IT. They provided little documented training. They did not have always effective communication. They did not analyze the metrics. Okay. Company D, 30,000 workers, 2,000 IT workers. 8 mainframes, 10 mid-range computers, 20 servers, 5,000 desktops. Company is a defense contractor, right? Strengths, they were committed to total quality and continuous process improvement. They were committed to doing excellent analysis of metrics. They were striving sequentially to integrate, standardize and streamline, and then automate the process. The weakness was undermining production acceptance, allowing high quality project to bypass the process of production acceptance. They were not allowing process to be streamlined due to cutbacks. So 83% score. So you can use this. I've given you some examples of MTBF calculations. MTTR, system availability is one bonus calculation, MTBF by MTBF, MTTR. These are all some good things. Hold on. I have one quick. To show you on for the 7R. So this is the case study that I'll share this document for the same with the golden pulp. So it's May 20th. Is at peak, the factory must process 100 tons of mango. If they stop for more than 4 hours, the fruits will rot. So how will you implement a high availability strategy with the 7 hours? So redundancy, have backup components like power supply, right? And then trust factor. The system will perform without failure for a specific time. The factory runs 24/7. So you get a server grade machine. Then robustness, the ability of the system to handle unexpected stress without crashing. The worker entered so many tons by mistake, still it will just give a invalid message. Ability to withstand a major disruption. So the fiber optic internet line connecting. So the system does not stop, the system automatically will switch to offline mode and it will run. Speed, the system acknowledges users' requests instantaneously. Generate end user report, screen freezes for 5 minutes. The manager thinks it's broken, clicks 10 more times. So create a responsive system. Repairability, quickly fix the system. One of the IoT sensor on the conveyor belt finally dies. Replace it within, if you are going to have the machine welded inside, you will have to shut down the machine, but you have a plug and play, 3 minutes, it's back. Bounce back, the ability to restore data and operation to the point where the disaster happened, right? So this is how you will handle the R's. This is the infrastructure availability process that we were talking about. Imagine an external IT auditor is visiting the factory in Ratnagiri to grade how mature their operations are. This assessment applies the criteria you provided to mango pulp scenario. So executive support, process owner, process documentation, whatever we saw, right? Assessing process efficiency, process metrics, integration, customer involvement, service metrics. So you will complete this document. Last, you do a process improvement plan. So how do you improve the process? Improvement area. Then last but not the least, about the assessing the infrastructure management process. So election IT consultant will come. He will check all these values. And out of 2 out of 5, 4 out of 5, all this, And then he gives a final scorecard of 32 out of 50. Golden Pup has a high quality executive support, excellent automation. However, the process suffers from low effectiveness in training and poor quality documentation. So what do you need to do? Top update run book, conduct failure drill. So this is how you will technically run through this. Okay. Thank you very much. Take care. God bless you. See you next week. Bye-bye.